Thanks to Henson Shaving for sponsoring today's video. The Earth's atmosphere may look empty, but it's really a complex and dynamic place, swirling with gaseous matter and thermal energy. Some of its most spectacular activity is best viewed at night. If you've ever watched a lightning storm or a meteor shower, the breathtaking aurora borealis in the north, or the shimmering aurora australis in the south, then you know what an incredible light show the sky can put on. But in recent years, with the help of highly sensitive cameras, researchers have been able to document a number of unusual, previously unrecorded light-producing phenomena. These occurrences, which happen high in the Earth's atmosphere, are known as transient luminous events. What are these strange phenomena? Why are they so elusive? And what can they teach us about the hidden workings of our atmosphere? I'm Alex McColgan and you're watching Astrum. Join me today as we look at incredible images of transient luminous events, as we explore and unravel some of the most mysterious and elusive phenomenon in the night sky. Let's begin with a remarkable image. It looks like a cross between a lightning storm and a jellyfish, doesn't it? This is a red sprite, and the formation you're looking at is fittingly called a jellyfish. It's incredibly big, spanning up to 50 kilometers, and originates at an altitude of 70 to 80 kilometers above the Earth. Sprites are short-lived events, lasting 3 to 5 milliseconds, and they travel downwards at blazing speeds, reaching 10% the speed of light. For years, sprites were only rumored to exist. Reports can be found as far back as the 18th century, but a theoretical basis wasn't published until 1925, when physicist C.T.R. Wilson speculated that electrical breakdown could occur in the upper atmosphere. However, despite years of unverified sightings, it would take more than 6 decades for their existence to be confirmed. So, what are sprites? Unlike lightning, which is extremely hot, sprites are cold plasma events, much like the reaction inside a fluorescent tube. Let's think about that fluorescent light for a moment. It requires a power source to ionize the gases trapped inside in order to emit light. As it happens, sprites also require an electrical discharge to trigger their fluorescent reaction. You see, inside a storm cloud, there is friction between rising ice crystals, which become positively charged, and sinking soft hail particles, which become negative. These positively charged crystals in turn cause a negative shield layer to form in the air above them. When a positive discharge happens in the form of a lightning strike, the cloud becomes neutralized, but the negative shield layer remains. We now believe it is this unstable, negatively charged shield layer that causes electrical breakdown in the upper atmosphere, producing sprites. It is even possible that sprites aren't especially rare. What makes them incredibly difficult to observe is that they occur high in the ionosphere, where they are often hidden by the storm systems that produce them. So, to see a sprite, you need a clear sightline over a thunderstorm, or perhaps a camera positioned above it. As you can see here, the International Space Station was lucky enough to get one in action. Sprites glow red because under the low pressure conditions where they originate, nitrogen emits low frequency red light where its molecules get excited. Compare this to auroras, which are usually green. That's because at the higher elevation where auroras occur, Earth's atmosphere has greater levels of oxygen, whose molecules fluoresce green when they get excited. But sprites don't always produce red light. Sometimes a sprite will set off a secondary event at a lower elevation. These secondary events, or tendrils, often appear blue. While their light is also produced by nitrogen, the higher pressure causes them to glow blue and near ultraviolet. As a result, some larger sprites, like the jellyfish we saw earlier, have a remarkable appearance, glowing red at the top and blue at the tentacles. Sprite tendrils aren't the only TLEs with a bluish tint. This event is known as a blue jet. Discovered only recently, blue jets are a distinct phenomenon also initiated by storm systems. In these events, the positive charge at the top of a storm cloud forms a leader with a negative shield layer above the cloud, producing a discharge that propagates upwards. This excites the nitrogen, making a spectacular cone-shaped jet that glows blue. Why blue? Well, remember what we said about how atmospheric pressure affects excited nitrogen gases. Blue jets occur much lower in the atmosphere than sprites, which is why they fluoresce a different color. There are also smaller TLEs called blue starters, but scientists believe they are simply failed blue jets. These diminutive cousins only reach 20 kilometers above the Earth. At the other end of the family is a separate phenomenon known as the gigantic jet, and it occurs much higher in the atmosphere, which is why the upper portion changes color from blue to red. We'll leave today with one of the rarest and least understood TLEs. These green or red phenomena are known as ELVES, a quaint acronym that stands for a mouthful. Its full name is Emission of Light and Very Low Frequency Perturbations Due to Electromagnetic Pulse Sources. Try saying that 5 times fast. Unlike sprites and jets, ELVES are diffuse, ring-shaped phenomena that occur even higher in the atmosphere. And unlike what the name suggests, they are huge. ELVES can grow up to 400 kilometers in diameter and occur 100 kilometers above the Earth. But despite their size, they are extremely short-lived events. They only last a millisecond, so brief that they can't be seen by the naked eye. While little is known about ELVES, we believe they are caused by an electromagnetic pulse produced by the discharge of an underlying thunderstorm. So, there we have it. An introduction to some of the most spectacular transient luminous events that have been confirmed in recent years. What other luminous phenomena may be lurking in the Earth's atmosphere? It's tantalizing to think about. And because this is still a fairly new field of research, we can only imagine what new surprises may be in store for us. Want more videos about weird atmospheric phenomena on Earth? Let me know in the comments. These phenomena, in part, have only been observed recently thanks to the advances in sensitive scientific equipment, and to have such precise equipment has required serious advances in manufacturing processes. A similar process has now happened with razors. Henson Shaving sells a razor that is built with the same machines that manufacture aerospace parts. Why? So that the blade is supported to incredibly tight tolerances, and it makes a big difference. Look at a traditional razor trying to cut a card, and then one of Henson Shaving's razors doing the same thing. Because the razor supports the blade so well and limits exposure to only 27 microns, it not only gives you a smooth shave, but reduces chatter and tugging. The design allows hair to be easily rinsed away, and the best bit, these disposable blades are available almost anywhere and are seriously cheap, about 10 cents each, meaning you'll only have to spend at most around $5 a year to replace them going forward. If you use the code Astrum at checkout, you'll get 100 blades for free. If this is something you want to check out, find the link in the description below. Thanks for watching. A big thanks to my patrons and members for supporting the channel. If you want to have your name added to this list too, check the links in the description below. All the best and see you next time.